So let me show you my screen. Oh, okay. Can you see my screen now?
No,
Yeah.
Yes.
I'm not seeing anything. Oh yeah,
Yes. Yeah. You're now seeing it.
Yeah, I can
yeah.
see.
Okay. Uh, we're talking about the different components of the LAN, local area network, and we stopped on hubs. Uh, if if you don't know what hubs are, basically what hubs are, they work like switches, and you can't tell the difference between a hub and a switch, but they are no longer used. Reason being, whenever they got information, they sent it to all the ports. But a switch, what it does, it knows it studies all the ports and knows who is where. So if it's sending information, you find that it will send to that particular port where that particular person is, instead of going through the whole process of sending the information to everyone. And basically, hubs most of the times they consider them more of as bus topology. If you remember topologies, Emma, do you remember topologies? Excuse me, is there anyone who remembers topologies? Okay,
Yes,
but yeah, do you remember topologies?
yes,
Yes, do you remember the bus topology?
yes, sir.
Yeah, what is it about?
Uh, Usually they are arranged in a straight line.
Yes, so they're basically arranged in a straight line, meaning that they are all connected to one particular wire. Most of the time they call it a vampire tap, meaning that they actually have to cut through the wire and then they make sure that it is permanently what uh, connected. It's like the way you used to play around with your your cables and what the switches and what at home. You used to cut through them, then you connect something else. So that's basically how they used to do it. They connect the computers like that. Get my point? So uh, there are two types of hubs: active and passive. The active one uses electronics to amplify the signal, but the passive one connects all ports electrically and usually not powered. So one uses power, one doesn't use power. So that's one way of easy to remember. So the active one is the one which uses power, then the passive one doesn't use power. Now repeaters. They are small devices that receive incoming electrical, wireless and optical signals and retransmits them to spots that the Ethernet and Wi-Fi data can't reach. So now what happens is, in most networks, like let's say at Isbot, you realize that the building is more of a flat. It's a flat actually, not more of a flat. Uh, so with a flat, you find that for you to connect one floor to the other, definitely, the Ethernet cables have a limit of 100 meters to avoid EMI, electromagnetic interference. Whereas if they travel for a long distance, they can easily be affected by EMI. So by putting that 100 meters, you create one cable for that 100 meters. Then you add another cable, but this time what you do is you put a repeater there. Because the repeater helps to amplify the signal, then it retransmits the signal to the network. That's why repeaters are used a lot in such areas in the network. If like let's say you're working in a large building, a repeater can do a very good job for you of sending the information from one area to the other area. You get my point? So most of the times you find that a repeater is connected to the switch. Actually, it's connected to the the Ethernet cables, and the Ethernet cables are connected to the switch. So something like that. So you find that it just sends the signals like that. So this is what they call a bridge. So just like normal bridges, you just try to picture the normal bridge and just relate it to the IT world. So this bridge connects two networks together. So, but nowadays bridges are no longer used, but they used to be used a lot in old networks. Are we together with that, guys?
Yeah.
Okay, now the famous switch. I don't know if someone is trying to join. Okay, it's fine. Is that a message? Okay. Oh, okay. Switches. I think I've talked a lot about switches, but uh, if you're trying to know what a switch does, basically, a switch was uh, took over the work of a hub of sending information from one port to the other. But the difference with the switch, it became smart. It was designed to be smart. Not it became smart. It was designed to be smart in a way that it will know that this person wants to receive the information, so I'll send it to this person. Remember in class when we had a demonstration of how to use a switch, where we connected your Ethernet cables, then we started sharing the information with each other. We send those things of ping, you remember them? You are Tisbad, guys. How we should talk about your anyway, Endgame was not for this year, it was last year. I was going to talk about Endgame. Uh, this year it was which one? This what's the name of that movie of Dwayne Johnson and Kevin Hart? Next Level. Have you guys watched it, guys?
No,
I thought these are things you're supposed to watch. They're supposed to be in your bucket list of things to watch this year.
What? Not everyone is a
I've been
fan of
watching
Kevin
old
Hart.
movies.
You guys never watched it up to now. You guys are not serious watchers of movies. It seems.
The spy movie.
The spy movie. You
Yeah,
guys,
like one is a secret agent or something.
you have not watched that Jumanji Next Level.
Oh yeah, yeah.
Yeah.
Oh, you see
Oh,
Jumanji.
no,
You see
I watched
Jumanji.
like a half of it.
So
Yeah,
you
I see
what?
Jumanji.
You
That's what they
watched
can
it.
understand.
You watched it.
Yeah, of course, of course.
Okay. I was going to wonder what is happening to this world one.
Uh,
Anyway,
bro.
so routers. Router is used to
Hmm.
connect different devices in a network. So basically, if you're connecting, like let's say to a Wi-Fi hotspot, most of the times that's more of like a router kind of system where you have an access point. Most of the times I usually call routers access points. You guys note that down. Most of the times in networks they usually put access point or router. So most of the times you find that those network switch require you not to keep on going through ceilings which are very weak and you end up killing yourself from there. You rather go with the router. Though the problem is routers, first of all, they're not so safe. Secondly, data, I was even going to repeat myself, but the security issue is big and information being taken in and out because it is very low. If you notice, most Ethernet cables have like let's say Cat7. That's 1 Gbps. So it means that the information is traveling in 1 gigabyte per second. However, say you have those issues of maybe your computer if it can handle that speed or something like that, or the ports. But generally, the cables are strong. Then you'll find that
Excuse me, sir, for me.
yes, what is happening? You also have short calls on online classes.
I think he went out of the room or something. I can.
Anyway, so yes, what was I talking about? Yeah, I was talking about connecting using an Ethernet cable to a route to a switch is much more. It can take in more information compared to an access point. They usually take in more information, so it's easier for you to transfer information very fast. Imagine you trying to download a movie or a series or something like that, or upload something. Most of the times the network is very slow. You get the point? Especially in Uganda here, then our internet is extremely slow. So you find that you have issues trying to just uh, download something or use something online or upload something compared to when something is being used using wires. It's easier and more convenient. And then network cable connectors. I don't know if I have my diagrams here, but I have a picture of the RJ45. Are you seeing? This is the access point. Then this is the bridge. This is then hub. As you can see, the hub looks like a switch, so you can't even tell the difference if it's not written on it or anything like that. This is a network interface card. Then switch is there. I'm not seeing this. I'm not seeing it wrongly. You have the internet. Why am I struggling? As you can see, this is how the stuff looks like. And I'm sure you have seen many of them. We even made one in class. So by the time you tell me that you don't know how it looks like, then there's a problem somewhere. And I might examine something like this concerning such stuff. Uh, Especially those color codings for the Ethernet cables. Pay attention to them very nicely. Do you still remember the colors? How you arrange them? Do you still remember that, guys?
Not properly. Somehow,
Okay.
let me run read the
I hope you recall them during
like
the exam.
the straight cables and the cross cable thingies.
Yes,
White,
those things.
orange,
Yeah,
orange,
those
green,
things.
white. Okay.
So pay attention to them so much and try to look through your books and see. Okay. Uh, so the British Naval Connector. If you look through the videos which I actually posted of recent, I talked about these things. Basically, it's part of the coaxial cables, which they used to use them a lot during those olden days. Especially the British used it for radio transmission. So that's why they ended up calling it the British Naval Connector, but that's the original name. By Neil Conseller. Our classifications of networks. I have a very good slide for this. I remember I created it. I saw it sometime. And I actually sent it in the group. So if take the time to go through it. Do you remember the classifications of networks? Guys,
Class A, class B, and class C.
we're not talking
Huh?
about IP addressing. We're talking
Oh,
about
okay, okay.
classification of networks.
I don't remember anything.
Also, done classification of networks.
What is
You don't
classification
remember
of
this
networks?
diagram?
Huh?
I remember strongly. I think I even I saw this. I posted the video
I
concerning such things
don't
But
because I
but
remember I
in
created this
order
thing during that time.
the graph you said that thing is not there. Classification. Oh yeah,
It's there. Check.
yeah, it's there.
Uh,
It's there.
These are all things which I've already talked to you guys about. So, as you've noticed, the first one underneath is the personal area network, then followed by the local area network, campus area network, then metropolitan area network, then wireless area network. And I remember there's only one guy who sent me the exercise which I gave in this thing. It was Dalton. I'd put an exercise at the end for people to send their work, but only Dalton sent the information because I
wow.
had given a task of going and researching about campus area network. So, to put it in an easy way, it's the way the different layer shells of a network. So, the more you get out of your rooms, the more you get out of the country, the more you get out of everywhere. As long as you're connecting online, there's a different type of network you're connecting to. Now, take for example, like most of you are in your rooms right now, isn't it?
Yes.
yeah.
So most probably you're using uh, a Bluetooth device. I have a feeling. I'm not sure, but uh, Bluetooth device probably to listen through the headphones, which are Bluetooth, or maybe even mouse. You know those mouse which are Bluetooth?
Yeah.
Yeah. Or some of you like playing your these guys who play PlayStation guys. PlayStation guys. Yeah, use those wireless pads. They also use Bluetooth. So you're all in that same bracket. So probably most of you use it, isn't it?
Mm.
Okay. So personal area networks are those networks which cover a distance of up to 10 meters. One common feature about the personal area network is that there are few devices and connection can be in a single room. So just like your rooms. So most of the devices usually connect through the use of Bluetooth. So that is also one thing you have to pay close notice to. Then is what they call local area networks. Now this one is the most common one for small businesses, uh, branches of banks. Uh, what else? Guys, give me. I'm the one only pitching, so you should also give me something.
Which one?
Local area networks.
Homes.
Homes, not so much. Homes, yeah, yeah.
Yes,
If you have a big
homes.
house, yes,
It's what we use here.
yeah, you're right. Homes. So
Uh,
for local area networks, these ones cover up to 1 kilometer. So,
two.
yeah,
But here it shows two in the soft copy.
what
The soft copy you sent, it shows 2 kilometers.
of this same document?
Yes.
Okay, now there's a confusion somewhere, but I'm very sure it's 1 kilometer. Probably there's a mistake
Okay.
somewhere I made. So this type of network usually deals with an office or of a single branch, home network, among others. This type of network has different options of cables and wireless options to be used. Ethernet cables, which we have already seen, repeaters can also be used, switches, which we have also seen, access points, or routers, which we have also seen. Then the metropolitan area network. So if you're dealing with cities, obviously the distance comes into play. So most of the times you'll find if you're moving around town, there are always those manholes. Have you seen those manholes? They usually you see guys entering in. There's some sort of pipes, kind of. If you have moved around town, at least you have seen it once or twice, guys. Anyway, those manholes they usually carry what they call those fiber optic cables. So fiber optic cables are used a lot for cities, especially if you want to send information very fast and very efficiently. They use fiber optic cables. So then there is also what they call wide area networks. Now wide area networks deal with a lot of things. What your internet service provider is providing you right now with the internet is part of what they call wide area networks. When you're able to access things from abroad, you're able to access the internet, all those things is due to the wide area network. I guess that's it. So then what's the next thing? bus, star, ring, and hybrid topology. Guys, do you still remember these things? I remember I've seen an image here. Who can take us through this? Quite self-explanatory.
I don't
About
even remember.
The topologies.
Can someone explain?
to explain like all of them
I don't know. I've
All of them.
forgotten.
about the
Okay.
topologies.
Okay. The bus topology, basically, you're using one wire, which is usually called the backbone. Reason being, it's called the backbone. When you cut off the backbone, there is no one who is going to receive anything. So this this backbone is connecting to these different devices, and the different devices connect to each other. And as I told you, they use what they call the vampire tap, where they literally cut through the wire and connect. Then there's what they call a star topology. A star topology is very common. If you have an access point, if you have a switch, it's usually a star topology. Reason being is there are many devices connecting to one single device. And the reason why it is very popular it's because first of all it's it's easier to use. Secondly, it easily transfers information from one port to the other. Uh, the other reason is uh, it's not fail proof, but it helps a lot. Each port is more like a hub and a bridge. Is someone trying to connect to it? So as you can see, it's usually a switch or router in the middle. So when you're using like Devanshu, you say that you always use Wi-Fi, isn't it? From someone else's
Yes.
data. I feel sorry for that person, but anyway, that type of thing is what you're doing. You're doing the star topology. So multiple devices
Okay.
are connecting through that Wi-Fi access point. So then there's what they call the ring. Basically, the ring is in shape of a ring, if that's how you can explain it. So it's in shape of a circle. Anything which is in shape of a ring, basically these devices connect to each other through one single wire. So this one is connecting to this one is connecting to that one like that. So the thing with this one is if information is being sent from here to here, it will either pass through this area or go through this one, then this one, then this one. And if you cut off one from the stuff, just know you won't be able to access the information. You get the point? And this one is,
Yeah.
yeah, this one is used. Okay, you'll find that in a network most of the times that they are using like these different network topologies, but in different occasions. Like let's say ISBAT. You find that in the labs they're using star topology because they're all connecting to the router, right? I mean the switch, isn't it? That box in the back. You remember that box in the back? So then for them to connect to maybe the server, they're connecting through probably ring. I'm just giving an example, probably ring, because that lab may be connecting to another lab, then the other lab is on she's connecting to the server. You get the point? That type of ring. So information has to travel from one lab to the other lab, then to the server. Something like that. You get the point, guys?
Yes.
Yes. So
Yes.
there's also what they call a hybrid. So a hybrid is a combination of two or more topologies in order to benefit their advantages in this hybrid topology. So what I've just explained is hybrid, where I say that most of the times you find that in a network, they're not using just one single topology. And there's one which we have missed. There's what they call the mesh topology. The
Yeah.
mesh, you have heard of mesh topology. So
Yes.
mesh, basically what happens is, I don't know if I should pick Paint or Photoshop. Which one do you want? But do you guys still practice using Photoshop? I only see one
No.
person who
No.
is active. Marvin, the rest of you, I don't understand. You left it when you finished the course that
No
semester.
one.
Okay. Why am I even struggling? I should have just. I'm trying to create a PC, but anyway, let me just pick it from the internet. So they are here. Guys, are you still with me?
Yeah, it's there.
Okay. Uh, Let me duplicate this thing. So now with the mesh topology, you'll find that this will be connecting to this. Then this one will be also connecting to this. This will be connecting to this. And it will also be connecting to this. Are you seeing what is happening? Like
So
basically
they
they're
don't have a
different.
main. They don't have a main server.
Main server. No, as in
Like a main computer. like others.
This is more like a fail-proof kind of. So what happens is if like one wire is being used up, let's say this one is being used up, you find that they will end up using another wire to go to the same computer. You get the point? Or this one is messed up, or there's an issue. You find that it will either transfer to one wire, either wires which works for it. That's the benefit of mesh topology. So you'll find that each computer is connecting to each other like 3 times or something like that. You get the point? 3 or 4 times. If there are 3 computers, they will be connecting how many times? What do you think? Because each and every computer connects to the other different ways. These ones are 1, 2, 3, 4, 5. So they're connecting 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one has 9 connections. So that is more fail-proof than ever. So it means that if one wire has issues, it goes to the other. You get the point? Herbert, are you with me?
Yes.
Yeah, so that's basically what it's used for. So
The, the
I've talked
hybrid.
about the topologies. So
You've left out hybrid.
I talked about it. I said you'll find most of the times that you're not using only like a star topology where you're connecting to the switch only. You find that the switch is also connecting to another device or to another lab, and that lab is the one which is connecting to the server. So if you combine both of them, the ring and the star, because that one of connecting to other labs is the ring. This one of connecting the labs with the computers inside it is the star. You get the point? Albert?
Yes, sir, I've got the point.
Yeah, so it's basically a combination of the different topologies for them to work together. So wireless area networks. Why so this we learn wide local area networks is more of the internet itself. If you put it into perspective, it's more of the internet. Most of the times it's usually considered as the internet. Then there is what they call Wi-Fi. Should I explain Wi-Fi to you guys? Because I'm sure some of you are using it. Divash, your dad is going to kill you one of these days for overusing his Wi-Fi. Um,
No, we got a Wi-Fi at home, so we won't give.
Bluetooth. Uh,
No, those five thingies like Bluetooth.
should I also explain Bluetooth?
No.
PlayStation users, you should be explaining what Bluetooth is. Since you use it but you don't know that you're using it. I'm sure you're
So
aware
you
that you're
do
using
know.
Bluetooth, isn't it?
Yes, you can even connect it on the phone,
Yeah.
on the pad.
So then wide area networks. Do you also want me to explain that one? Okay. Let me explain things which some of you are already rusty about it already. IP addressing. So I remember I think I spent like 3-4 weeks on this topic, or even more, a full month. But basically, if you look at IP addresses, it's a way of connecting to put it into perspective. I'm trying to get for you a good picture of it. If you want to connect different devices by giving you an IP address, you're able to connect to different devices. It's more of like your name or your alias on the internet. You get my point? Your MAC address is your name, then your IP address is that name you put on Facebook. Some of you put weird names on Facebook, or nowadays there is TikTok, and there is also, I think people use more of Instagram nowadays, isn't it? Even for chats. So that weird name you put is usually the alias. So that alias is more of like your IP address. It enables you to connect to different devices. So whenever you try to connect to the internet, you're given an alias. Basically, what's happening whenever you subscribe for MBs, your internet service provider gives you an alias, which is your IP address, to connect to the internet. Though obviously there are more technical things concerning that, like what they call DHCP, which we were supposed to go through this semester. It basically deals with providing internet. I mean, providing IPs to computers without you manually putting it in. That's basically what it does. Then what we are going to learn is how to do it, so that it can do it automatically. You get my point? So most of the times you'll find that your ISP has some sort of DHCP server, which is it's designed to give you IP addresses. So whenever you subscribe for data, it gives you an IP address. You get my point? So try to apply the same knowledge here. So an IP address is an address to a device to help devices to communicate with each other. So basically, that's it. So there are two major types of IP addresses. There's IPv4 main versions, IPv4 and IPv6. Now IPv4 was the first and is still being used right now. IPv6 is being used but silently. Should we call it a silent? How do you call them? Those investors, silent investor. That's the IPv6. It's more of like a silent investor. Basically, what happened is they thought that the IPv4 addresses were going to run out, so they ended up coming up with IPv6. But the silent investor wanted to come out to be the main investor, but up to now the IPv4 has refused to leave the spot. That's how I'm trying to paint the picture, but literally the IPv4 addresses are not yet done. That's why they're still using IPv4 up to now. You get my point? Guys, am I talking to myself or what?
We are there.
You're there.
Yes,
We're
sir.
there.
Okay. So IPv4 has what they call octets. So octets are basically like portions for you to address your IPs. They're like more of cubicles, and they have a particular amount of space required in those cubicles. There are particular rooms which they're more like particular rooms which are set to a particular limit of number of people. So that's the same thing with octet. So each octet has a limit of 8 bits, which is, if you count the 8 bits, they have what they call 8 values inside as 8 bits, which are 255. I remember we used to do these things a lot. 128, 64, 32. Remember those things? Guys, you
Yes.
remember those stuff?
No.
Okay, we shall go through them. Um, so let me first try going through the notes. So each of these octets has 8 bits. In each of these octets, the limit is 8, which I talked about. Now this 8, if you combine those different 8, since there are 4, IP version 4, uh, if you calculate 4 times 8, you get 32. So there are 32 bits in the different octets. Then what else? In these 32 bits, we have what they call 8 values. And these are the 8 values which I was talking about. I was hoping you remember them. 128, 64, 32, 16, 8, 4, 2, 1. Divanshi, do you remember them?
What?
Good Lord. Divanshi, where have you been?
I've been here.
You have been here.
Yeah.
If you have been here, then what was I talking about? Anyway,
The
oh,
IP
sorry,
address.
sorry. Sorry for that, Divanshi. Anyway, so uh, 8 bits. In these 8 bits, there are 8 values. The first one is 128, followed by 64, 32, 16, 8, 4, 2, 1. So you find that in each network and in each octet there are 8, and this 8 has 8 values. Just by default, you just know that that's how things are. I don't want to say it's more of cramming, but it's more of like that's how it has always been since they created IPs. That's how it has always been. And the 8 bits is equals to 1 byte. And they're telling even that the sum is actually equals to 255. So if you go further, uh, as the internet grew, they realized that also normal users wanted to use the internet, like us the normal users, not those military guys. Because the internet was initially designed for those military guys and plus maybe universities. Because most of the testing of the internet was done by those universities, those American universities. So uh, they decided to give IPs to work commercially for people to use. So you'll find that if you want to purchase such things, it's available, but obviously there are particular organizations which provide this. There are companies like I think is it IIS. Yeah, I think it's the IIS.
Pardon?
There's a company called I. Is it IAS or IIS? I've forgotten. It deals with assigning IPs to infrastructure as a service. Good luck. Okay, I forgot the name completely. But there's a particular organization, like the way ISO is like that, that international organization for standardization. There's also a company for assigning IPs. You get my point? So they assigned IPs to be used commercially. So they gave different ranges. So from class A, we have from 10.000 to 126.255.255.255. Then for class B is 128.0.0 to 191.255.255.255. Then for C is 192.0.0, then 223.255.255.255. This you need to master. If you What I want you to pay more focus on is those first octet, this 10 and the 126. That is class A. Then 128 to 191, class B. Then 192 to 223, that's class C. You get my point?
Yeah.
So
So you keep on adding. Is it something? I'm saying
adding,
nothing.
basically that's how they grouped them. So then is what they call network parts and host parts. Now I don't know if I want to complicate things. Let's You guys first digest all that, then we shall start with this in the next class. Are you good with
Okay.
that?
Yes.
Yeah.